Welcome back. I'm Mrs. Edwards, and we are going to be finding derivatives from a table. This is kind of part 2 of finding derivatives from graphs and tables. So let's go ahead and get started. We have a table of values for f and g evaluated at 0 and 1, and also their derivatives evaluated at 0 and 1. And we have this equation here, 5f of x minus g of x, and we are being asked to find the derivative of these functions and then evaluate them at a specific x value. If we go to find the derivative of 5f of x minus g of x, let's start with just 5f of x. We don't have a special rule here. We don't need to use the product rule because 5 multiplied by f of x is a constant times f of x. So we can just kind of set the 5 off to the side, find the derivative of f of x, which is just f prime of x, and multiply back the 5. So we're going to have 5f prime of x, and then subtract g of x. We also don't have any special rules for addition or subtraction or multiplying by a constant. So the derivative of g of x is just going to be g prime of x. So there's our derivative. Now we just input 1, go to our table to find the answers. So if I go to my table at x equals 1 and I look across, f prime at 1 is negative 1/3, and then g prime at 1 is going to be negative 8/3. So I'm just substituting in the values from the table, and then a little simplifying, and we end up with the answer 1. All right, here's our second one. F of x multiplied by g cubed of x evaluated at x equals 0. Here's one of those examples of what I like to call a misplaced exponent. Like, yes, it does mean g of x to the third power, but I really do not care for this notation because it is not conducive to performing derivatives. So first thing I'm going to do is just simply rewrite the original problem, and instead of saying g cubed of x, I'm going to say g of x cubed. Now I'm ready to take the derivative, and I need to notice that f of x is being multiplied by g of x cubed. So I needed to apply the product rule because we had two things multiplied together. They both had x's. So we're going to have f of x, as you see here, times the derivative of g of x cubed. I haven't actually taken the derivative of that one yet. I'm just setting it up. So the first one times the derivative of the second plus the second times the derivative of the first. Now let's focus here on finding the derivative of g of x to the third power. If we just had x to the third, our derivative would be 3x to the second power. But instead of having just plain x to the third, we have something more than x. We have something ugly. So we're going to apply the chain rule. So we're going to still take the 3, move it to the front, and subtract 1 off the exponent, but we have to chain on the derivative of g of x. So here we have 3 to the front, g of x to the second power, chaining on the derivative of g of x. And I'm just bringing down everything else. We're ready now to substitute in 0 because we wanted the derivative at 0. Going up to our table, we just start finding the values. So f evaluated at 0 is 1, g evaluated at 0, going across from 0, I get 1, and so forth. Little simplifying, 3 times 1 squared is 3, and 3 multiplied by a third is 1. 1 times 1 is 1. And then we have 1 cubed times 5. And so our final answer is 6. Here we have two pieces that are being divided. So when I take the derivative, I'm going to need to use the quotient rule. The entire numerator is what I call high. The entire denominator is low. So if we apply the quotient rule, we start low, end low, over low squared. Low d high, so the denominator times the derivative of the numerator, minus high d low, so the numerator times the derivative of the denominator, all over low squared. We still have just a little bit to take the derivative of, so let's focus right there. The derivative of g of x is just g prime of x, but the derivative of 1, the derivative of a constant, is 0. So that just becomes g prime of x. Just copying all of that down. Now we're ready to substitute in 1. Going to my table, I start finding the answer, so g of 1. So I go across from x equals 1, and when we substitute in 1 into the g function, we get negative 4. F prime of 1, go across from x equals 1, and then to the f, so we'll get negative a third, and so on. So I'm just substituting in our answers. We have a little bit of simplifying to do. For example, negative 4 plus 1 is negative 3. Negative 3 times negative a third would be positive 1. Negative 3 multiplied by negative 8 over 3 would be plus 8. And then in the denominator, we have negative 4 plus 1, which is negative 3 squared, which is 9. So keep on simplifying, and we get the answer 1. Next up, we have finding the derivative of f composition g of x. All right, if you just had f of x, the derivative of f of x would be f prime of x. But since we have more than plain x, right, instead of just f of x, we have f of g of x. That g of x is the input function. And so we're going to need to chain on the derivative of that input function. I like to think of that input function as just ugly, because it's more than plain x. So if we had f of x, we'd have f prime of x. Since we have f of ugly, we have f prime of ugly. Chain on the derivative of ugly. So in other words, I'm going to have f prime of g of x times the derivative of g of x. Now I just need to put in the 0. Look up in my chart for the answer to g of 0 and g prime of 0. Then I can find f prime of 1, since g of 0 equaled 1, f prime of 1. So looking back up in my chart for f prime of 1, go across from 1, look there, and it's negative a third. And so we take negative 1/3 multiplied by 1/3, and our final answer is negative 1/9. Here is another composition function, and it's almost exactly the same as part D. So you might want to pause and just see if you can do this one. But let's go ahead and let's get to it. So if you were to find the derivative of g of x, it would just be g prime of x. But since we have more than plain x, we're going to need to chain on the derivative of that, in this case, f of x. So derivative of g of x would be g prime of x. The derivative of g of yellow is g prime of yellow times the derivative of yellow. Okay, g prime of ugly times the derivative of ugly. All right, so now I just need to substitute in 0. Go up to my table, find the answer to f of 0. So go across from 0 until I get to the f function, and that equals 1. Go across from 0 to f prime, and I get 5. So there are my values. Next, I can find g prime evaluated at 1. So go across from 1 until I get to the g prime, and I get negative 8/3. So now we have negative 8/3 multiplied by 5, which is 5 over 1, numerator times numerator, denominator times denominator. We get negative 40 over 3. Here's another one. Okay, that exponent. We have a bunch of stuff here inside of grouping symbols raised to the power of negative 2. That input function, the giveaway, it's what's inside parentheses or what's inside grouping symbols. So all of that, g of x plus f of x, that's the input function. That's our ugly. So we have ugly raised to the power of -2. Well, if we just had plain x to the power of -2, we would move -2 to the front, subtract 1 off the exponent. But since we have yellow to the -2, we're going to put -2 in front, yellow, subtract 1 off the exponent. Okay, so -2 to the front. We have the same thing, subtract 1 off the exponent. -2 minus 1 is -3. But then we need to chain on the derivative of that input function. In other words, what's in yellow there? So I'm going to say it with yellow. -2 to the front, yellow, subtract 1 off the exponent to the -3 times the derivative of yellow. Okay, after we get that derivative, we just substitute in 1. Oh, sorry, my bad. Let's back up for a second. I haven't found all the derivatives yet because I'm going to chain on the derivative of yellow. So when I want to find the derivative of g of x plus f of x, no special rules for addition and subtraction. So the derivative of g of x plus f of x is just g prime of x plus f prime of x. All the calculus is finished, so I just need to bring down this part here on the left. And now I am ready to substitute in 1. So if I substitute in 1, go up to my table and evaluate g of 1. So going across from 1, go to the g function, I get -4 and so on. So I'm just substituting in those answers. We have a little bit of simplifying to do. -4 plus 3 is -1. -1 raised to the -3 power, that just puts that to the denominator, so it's 1 over -1 to the positive 3. Okay, so you get -1 times -2, and then -8/3 plus -1/3 is -9/3, which is then -3. So when we combine, we get -6. Next, we want to find the derivative of f of x plus g of x. Hopefully you're starting to see that need for the chain rule. If I just had f of x, the derivative would be f prime of x. But we've got a lot more than x. We've got all of that. So that's my input function. I'm going to need to chain on, meaning multiply by, the derivative of that input function. So if we had f of x, the derivative would be f prime of x. But we have f of yellow. So it will be f of yellow times the derivative of yellow. That yellow is your input function, that ugly function. All right, so f prime of yellow times the derivative of yellow. The chain rule is applied anytime you don't have just plain x. And, well, I'll leave that. Never mind. Okay, so next let's focus on finding this little derivative here. X plus g of x, we want to find its derivative. The derivative of x is 1, and the derivative of g of x is g prime of x. We don't need to do anything special there because we don't have a special rule for addition and subtraction. We can just find the derivative straight across. The derivative of x is 1, and the derivative of g of x is g prime of x. Now I'm going to bring down the left-hand side. And we're ready to evaluate our derivative at 0. Substitute in 0 for all those x's. We could simplify inside this first set of grouping symbols. 0 plus g of 0 is just g of 0. I'll go ahead and do that. Okay, next we'll work our way out inside of the parentheses, g of 0. Going to 0 up here, the x value, and across. The answer to g of 0 is 1, and then the answer to g prime of 0, going across from 0, the answer is 1/3. Okay, so I'm going to make those substitutions. And then I can continue working my way outside, right? I did what's on the inside parentheses, g of 0. Now f prime of 1 is negative 1/3 from our chart. And simplifying a bit more, 1 plus 1/3 would be 4/3, and 4/3 multiplied by negative 1/3 is negative 4/9.